Good morning, everyone. Welcome back to the lab session. So, in a previous lab, I think we have covered a fractional knapsack, right? And in today's lab session, we are going to cover a DFS and BFS algorithm. Now we already understand the concept, so let me explain it again. DFS, how DFS work, and then you have to solve one example, and then after we'll move forward to the C program. And then in our next session, or in our next step, we are starting with the BFS. Okay, so now can anyone tell me what is DFS? What do you understand by DFS? Anyone? Do you know what is depth first search algorithm? Or you forgot it? Depth first search. You have already studied this in a data structure. Still, you are not able to remember it. BFS and BFS. What is depth first search? As per the name only, you have to tell me, no? Anyone remembers it? Yes or no? If you don't know, then please don't waste my time. See, DFS is depth first search algorithm. See, pay attention in the class. Okay. Whatever you are doing behind this meeting, you have to stop it. Your midterm is in the within 10 or 15 days. And if you are paying attention like this only, you are not able to pass the subject. Already you got the mid one marks. You know that you are not able to pass the subject. So start preparing from now onwards and pay attention in every class. So DFS means depth first search algorithm. This we have already covered. Let me just go through the concept, how we are doing it. So the depth first search here, the idea is what we have to visit each and every node, we have to traverse it, right? And in a depth wise, we have to traverse the node. If there is no adjacent node, we have to backtrack to the previous node, right? The problem is what we have to we have a cycle in a graph, so maybe nodes can be visited infinite time. So this is the problem. So to get the solution for this, we will use a Boolean array to keep track of the visited nodes. Here the stack data structure is used. Fine. How we are going to move? Let's suppose this graph is given. You can start with any node. Multiple answers are possible. The empty stack is given. We have to print the output. So you can start with any node. Let us start with visit node A. You will visit it. You will push it onto the stack and you will print it. Okay. Stack में push किया, print किया. Then find the neighbor of A, that is B and C. Now out of B and C, you have to take only one. Okay. So let us visit B. Visit B. Push it onto the stack. Print B. Okay, so push it onto the B, then print B. So neighbor of B will be D and E. Okay, neighbor of B will be A, D, A. A is since already visited, don't need to write it. So D, E. Visited D, push it onto the stack, print D. We have printed. Find the neighbor of D, that is B, E, F. D is already visited. You can choose E or F. Let us visit E here. Okay, after visiting E, push it onto the stack, print E. So A, B, D, E is printed. Find the neighbor of E, that is B, D, F, C. Now B and D is already visited. We have two choices, either visit F or visit C. So let us visit C, push it onto the stack, print F. Okay, F is printed, neighbor of F, that will be D and E. Now you just see D and E is already visited. Now how you can say this tree is not completed? We have not visited all the nodes, right? One is remaining. So how you can get to the C? So to go to the C, we have to backtrack to its parent node, right? So last node we have visited, that is F. So we have to pop it from the stack. Okay, we popped F from the stack. Now the current node is E. Find the neighbors of E, that will be C and F, B, C, F, D. Right? Since B, F, and D is visited, C is remaining. Visit C, push it onto the stack and print C. So push it on the stack, print C. Find the neighbors of C so that we can find out is there any remaining nodes. The neighbors of C will be A and E. E is already connected, but A is not connected. So A is previously visited, so you will represent via backage. And pop C, now current node is E. All the nodes are visited. Node E, neighbors of E are B, C, D, F. Now D, F, and E is connected, so we have to connect via B with the backage. Now pop E, E is pop. Now find the neighbors of D, it will be B, E, F. B and E is connected, you have to connect F via backage. Now pop D, now B is there, neighbors of B will be A, D, E, all are connected, pop B, and then finally pop A. So after popping A, you will have empty stack. So this is the stopping condition. When you are having an empty stack, you will stop. Okay. And what are the rules here? Select an unvisited node, visit it, and treat it as a current node. Find an unvisited neighbor of current node, visit it, and make it as a new current node. Then current node has no unvisited neighbor, backtrack to its parent and make a parent a new current node. And you have to repeat the same step until you got the answer. Fine. So this is the algorithm. Like first we will start with any node. We will visit it. We will keep one in visited area. Initially, we have not visited any node, so we will mark it as a 0. Once you visit it, you will turn it into 1. Then you will find the adjacent vertices of that particular node. If it is not visited, then visit it. Again, you have to apply the DFS algorithm. Right? This is the algorithm. Based on this, you have to do the C program. Now for this graph, you all of you just start with the different nodes. No one will start with the same thing. Okay, apply the DFS algorithm and then give me the answer, what answers you are having. Okay, try to solve this example quickly using DFS approach. I'll give you 10 minutes time only. What answers you all got? Write down your answer. Everyone write down your answer quickly. If you want attendance, then write down your answer. Otherwise, you are not able to get the attendance for today's session. If you need more time, 5 minutes, 5 minute time, I'll giving you. Within this time only, you have to solve it. Okay. Okay, so those we have set it from 0 to 1, 1 to 7, 7 to 2, 2 to 5, 5 to 6. Then backtrack to 5, 0, 1, 7, 2, then 3, 4, 8, backtrack to 4, 3, 2, 5, and 6. Okay, Anurag, your answer is correct. 0, 8, 4, 3, 2, 5, 6, 5, 0, 2, 7, 1. Okay, Sanskar, your answer is correct. Okay, Nasib, you are correct. Okay, Uday and Dinesh, you both are correct. Mukund, let me just verify your answer. 6527 10843, and yeah, you're correct. All of you are correct. You got the correct answer, right? Fine. So now it's time to do the C program for a DFS first. So what you will do here is, like, see, we have already written the algorithm, right? You just have to draw this graph. Now how we are going to take this graph, because in a C program we are not able to draw the graph. Okay, so you have to provide what, the vertices and the weights, right? All these things you have to provide. Or one thing you can do is you can provide the adjacency matrix. So try to do this. Try to prepare adjacency matrix, and then initialize all the nodes to 0, and then write down the same logic for the as for the DFS we have written. Okay, so you will get the answer. So everyone, try to do the C program by for DFS. This is the algorithm. I have kept it here. I'll give you 10-minute time to do this, and then after I'll show you the program. Okay. Okay, so now let me show you the code for DFS algorithm. Okay, so first of all, we will create a function void DFS. Will pass integer vertices. We will take one graph array, two-dimensional array, as we are going to store it in a matrix form, and we will take one visited array and n for number of vertices we are going to store. So we will call the main function. We will start with the, we'll print a number of, we will ask user to enter the number of vertices. We will store it in address of n. Then we will ask user to enter the adjacency matrix. Okay. I is equals to 0 equals to 0 to n and j equals to 0 to n. You will ask user to store adjacency matrix. Then all the nodes are initialized to 0. Visited I is equals to 0. Now let us start with node 0 or any of the node you will start, and dfs function will be called. Okay, integer I, this 0 will, this vertices will be passed here. Now integer j printf, we will print the node, then we will mark it as a visited, and then we will find out the adjacency vertices. If the nodes of the adjacent vertices are not visited, right, and g of ij equals to 1, if there is a direct edge from that node, then we will visit that node. Okay, suppose 0, we will start with a 0, and there is a 0 to 1, there is a one node. Okay, if there is a edge, then we will represent it via 1, otherwise we will represent it via infinity. Okay, so the node is visited. No, if it is not visited, and if there is a edge, then you will call dfs again. Okay, so same procedure is repeated again and again. So I'll run this code. Just a second, I guess I have not shared the screen, right? Let me share a screen so that you can visit it. Right here, you can check it here. See, this is a DFS function, a graph. We will store the adjacency vertices, visited array, ask user to enter the number of vertices, adjacency matrix, and then initialize all the nodes to 0. We will start with any source node you have to provide here. This function will be called. First, you will print the node. Okay, I node will be print. Then from I, you will mark it as a 1. And from I, you have to find out the adjacency vertices. If it is not visited and if there is a direct edge, then you will call the DFS function again. Let's say there are 4 in this graph. Okay, I have to enter the adjacency matrix, but let me first draw this graph. Just a second. Okay, so let's suppose we are having 4 nodes. Okay, let me share my screen again. So for this, let us build the adjacency matrix. Here it is a 0, 0, 1 to 2. Yes, there is a direct edge. 1 to 3. Yes, 1 to 4. Yes, 2 to 1, 2 to 3, 0, 2 to 4. Yes, 3 to 1. Yes, 3 to 2, 0, 3 to 4. Yes. Okay, I'll enter this matrix. For this graph, we are going to find the DFS. So 0 1 1 1 1 0 0 1 1 0 0 1 1 1 0. So this is how the nodes are going to visit 0 1 and 0 1 3 2. Okay, let us consider this is as a 0 node, 1 2 and 3. Okay, if you are setting from 0, then multiple orders are possible, 0 to 1, then 3, then 2, right? Another way is what? 0 2 3 1, then 0 3 2 and 1. So these are all the possible order, right? So in this order, these nodes are going to visit. Fine. So I hope this is clear to everyone. DFS algorithm, right? Same way we have to do for the BFS algorithm. Okay, so BFS also we will do the same. So breadth first search, here we are going to visit the nodes in a level. Okay, one by one level, we are going to visit each and every node. So traverse the nodes in a layer. Here is the cycle. So because of the cycle, we can visit a node in an infinite time. So first we will visit 1, then we will visit 2, 3, then we will visit 4, 5, like this. And to keep track of the visited node, we will use a Boolean array. Flag 0 for unvisited node, flag 1 for visited. Here queue data structure will be used. In a queue, data will be inserted from the rear, and from the front, we are going to delete it. The same example we will take. Visited Boolean array, initially we are having 0 0. Queue we will take, will print the data. Let us start with any node. Visit v, mark it as a 1, insert it into queue, print it and pop it. Pop 1 from the queue, find the neighbors of 1, that will be 2 and 3. So 2 and 3 will be pushed into the queue. We will visit it, 2 and 3, mark it as a 1, push it into the queue. Okay, we already have printed 1. Now from the front we delete 2. So delete 2, print 2, then find the neighbor. Neighbors are 4 and 5. So we'll push it into the queue. 4 and 5 will be inserted into the queue. Mark it as a 1. So 3 is already there. Then after you will insert 4 and then 5. So now you can delete 3. So delete 3, print 3, find the neighbors of 3 will be 5 and 1 5. So 1 and 5 is already visited. So no need to visit it. Simply pop, we have already popped. Now let us go ahead next step. Now from the queue, you have to delete 4. So pop 4, print it, find the neighbors of 4, that will be 2, 5 and 6. So 6 is not visited, visit 6. So push it into the queue. So 5 is already there, we will push it. Now pop 5 from the queue, print it. 1 2 3 4 5 is printed. Now find the nodes for the 5, that will be 2 3 4 6, all are visited. Okay, so simply you will pop 5 from the queue, and now you will have only one element, which is a 6. So what you will do, find the neighbors of 6 will be 4 and 5 is already visited. So we have already printed 6. You will pop 6 from the queue. Now since queue is empty, you will print the output, which is 1 2 3 4 5 6, and you can exit the algorithm. Fine. So this is the algorithm, and we will take a queue. Whenever the graph is having unvisited node, we will make it as a visited node. We will store it in a V, mark it as a 1. We will push it into the queue. While queue is not empty, you will delete the data and store it in X. Then you will find the neighbors of this X. You will visit all the neighbor nodes, and you will insert it into the queue, and again you will follow the same thing, right? So you just do one thing for this example. Try to find out the BFS or This example, try to find out the BFS. Okay, same way, but now you have to do it, level by level. Start it with a zero. Start with a zero, and level by level you have to visit every nodes. Okay, and tell me what answers you got. Everyone, quickly do it. I'll give you 5 minute time to do this. Okay. What answers you got? Everyone tell me for using BFS. Write down your answer in the chat box. Everyone write down your answer in the chat box using BFS. काम तो करे तो Okay, so okay, so that is the correct answer. You get. Okay, fine. So now let us move ahead to the C program you have to do, right? You have to take a graph and you have to write down the same logic. I'll give you 10-minute time to do this, and then after I'll show you the code. Fine? For BFS. How you are going to do it? Sure, see, various functions we will create. First of all, you have to create a graph, then you have to do the traversal, and then you have to do the algorithms logic will be there. Okay. So just try to do it by yourself and then I'll explain. Because here for insertion, deletion, we have to write the separate functions, right? So total, there will be total 6 functions are there. Insertion, deletion, then if there is a empty, then what we will do, right? Everything we have to do. So do it right now, just do it by yourself and then I'll explain it. Fine. So quickly perform the C program. Okay, so let me explain the program first. Okay, because I guess this is a bit difficult for you. Okay, now we just see here. First of all, we will include the library. Then we have defined the maximum capacity, like infinity. Whenever we are having infinity, we are defining with some value. Okay, now we are having three stages. One is the initial stage, waiting stage, and visited. Okay, so let's say whenever we are starting with the initially, we have not visited any node. So all the state of the node will be initial. Then you visit some node and you find out two neighbors. Then whenever you are pushing into the queue, at that time the state of the uh, uh, status of this node will be waiting, and when finally you will visit it, it will be converted into the visited state. Okay, number of nodes will be defined with n. We have to ask user to enter the adjacency matrix. To store this state, we will use this array. Then we are having some function. First of all, we will create a graph. Then we will call this BF traversal function, in which we will assign this initialization part. And then we will finally call the BFS function. Okay, as we are using queue, you have to define one queue. Front and rear will be set to -1, -1. Then in the queue, we are performing three operation. Like first, we will insert it into the queue, then delete it into the queue. When we are going to delete it, whenever the queue is not empty at the time, we are going to delete it. Okay, so let us start with the main function, create a graph. So first of all, let us create a graph. This function we will go void create a graph. Here we have defined the variable like count, max age, origin, and destination. Okay, so first of all, we'll ask user number of vertices. How many vertices will be there? We will store it in address of n. Then based on this number of vertices, we will calculate the maximum number of ages. That is n into n minus 1 will be ages in this graph. Then we will start with the count 1. Count is less than or equal to max age. Okay, we will start with 1. Whenever this many ages are there, we have to stop. Okay, and we'll ask user to enter the ages, and the user will enter origin and destination. Okay, now just see, whenever there is a minus 1, you have to quit. Okay, so when origin equals to -1, destination equals to -1, you will break the break entering. Whenever you will check if origin is greater than or equals to number of elements, like let's suppose 5 ages are there. If it is greater than n and destination is also greater than n, or if it is less than 0, then you will ask user to print the invalid ages. You will decrement the count. Okay, else what you will do, you will provide this adjacent origin and destination, you will assign what it means. There is a direct age from origin to destination. This is the another way you can create a graph. Another the first way is what in the first example we have done. You can do it like this also. Fine. So simply you will ask user to enter the adjacency matrix, and based on the matrix you can write down the algorithm. Fine. Now after creating this graph, we will call the BF traversal function. So here we will go integer. We have defined nodes. We will cover all the nodes 0 to n. We will assign the state. Sorry. We will assign the state of all nodes as initial. No nodes have been visited, right? So we will assign the initial. We will we will ask user to enter the start vertex for the BFS algorithm. We will store it in address of V. And then we will pass this V into BFS algorithm. So we will pass this vertices here. We will insert into the queue. We will be inserted into the queue. So this function will be called insert queue. Okay, so to insert it into the queue, first we have to check whether the queue is full or not. If queue is full, then we are not able to insert it. So you will check if rear equals to max -1, then you will print queue is overflow. Else what you will do, you will check if front is equals to -1. Yes, then you will increment front by 1. You will increment rear by 1. And in a rear, you will insert the vertex. Okay, after inserting it, what you will do is here, you will initialize the vertexes as a waiting state. Suppose we have started with node 0. You have passed node 0 into this BFS. We have inserted into the queue, 0 is inserted, and then you will change its state to waiting state. Now, while queue is empty, queue is not empty, because in the queue we are having some data. Queue is not empty. So what you will do, you will delete the data, you will store it in a V. Okay, you will print it, and then you will change the state of that no particular node visited. Now, after that, what you will do, you will find the adjacent vertices. Okay, V to some other nodes. You will find out the adjacent vertices of this V. If it is 1, if there is a direct edge from 0 node and rest of the other nodes are having a state as an initial, you will insert it into the queue and you will change the state as a waiting state. This procedure you have to repeat it. Once you do it, then you have to print the data. Okay, now here, to delete a data, how you can delete it? Again, for the example queue, you have to check if front equals to -1 and front is greater than 1 or greater than rear, you will return 1, else you will return 0. And to delete it, to delete the item, you will check if front equals to -1. If queue is empty, then you are not able to delete it, right? So queue is underflow, you simply exit. Else what you will do, you will delete the item from the front, you will increment front by 1 and you will return the delete item. That deleted item will be stored in this way and you will print it, you will make it as a visited, and then you will find adjacent vertices. If their adjacent neighbors are state is initial, you will insert it into the queue and again you will do the same procedure, right? So let me run this program. Let's say number of vertices will be 4. Page 1. Just a second. Just a second. Let me run it again. As we have started from 0, so we have to start from 0. Okay. 4 vertices will be there. 4 vertices will be there. 0 to 1, 1 to 2, 2 to 3, and 3 to 0. Then -1, -1, 0. So in this order, 0, 1, 2, 3, all the nodes are going to visit. Okay, 0 to 1, 1 to 2, 2 to 3, and 3 to 0, we are having the edges. So in this order, we are going to visit it. Okay. So if we are entering 4 vertices, it means 4 into 3. Total 12 vertices are possible. Okay, till that you can enter. So it is dependent upon your graph. You can enter till 12. Right? So this is how it will give you the answer. So I guess this is clear to everyone. Right? So let me conclude the session here. Today we have completed DFS and BFS algorithm with some example. Right? In the next session, we are going to complete Prince and Kruskal algorithm. Right? So thank you everyone. I hope you enjoyed the session.